Hello and welcome to this 4IT techELITE session looking at data analytics on AWS. This is the second of a series of 3 technical webinars hosted with Amazon Web Services and will be presented by 2 AWS solution architects, Nitin Tiwari and Ahmed Zamzam. The third session will be at this time next week, looking at AI and machine learning on AWS. So this evening we will enjoy a presentation from Ahmed, followed by an on-screen demonstration by Nitin. These will both no doubt generate questions which I would ask you to note in the chat function of your GoToWebinar control panel, and we will spend the final portion of the session looking at as many of these as we have time for before closing at 7:15. I'll hand over the screen now and welcome our first speaker, Ahmed Zamzam.
Thank you, John. Yeah, so hi everyone. Thanks a lot for joining us in this session on data analytics, where we will basically walk you through our data analytics portfolio on AWS. So as John mentioned, my name is Ahmed Zamzam. I'm a solution architect based out of the UK. So I predominantly work with UK-based customers across many different industries. And so I get the privilege to work on many different use cases at the same time. I'm also joined by Nitin, my colleague, who will be doing a short demo for us a little bit later on. Nitin, would you like to introduce yourself?
Sure. Hi everyone, this is Nitin Tiwari. I'm also a solutions architect at AWS. And I am in the same team, mainly looking after in the territories, in the small and medium-sized business customers, across the depth and breadth of the AWS services and features. So here we go. We are all ready to give you a good time in learning.
Thank you, Nitin. So before actually we get started on the different services that we offer in the data analytics space and how AWS can help you implement different use cases on data analytics, I would like to take a step back and emphasize on the importance of data. So according to The Economist, and not only The Economist, but also other major entities around the world, they say that the world's most valuable resource is no longer oil, but data. And this statement in itself, it's also backed by data. So one Gartner report says that around 63% of CEOs around the world, they say that most probably within the next few years, they will change their business model and they will have to rely on data to make those important business decisions. The same report says that around 45% of CIOs around the world, they say that the #1 area that they would like to invest in is data analytics and business intelligence. So you can see here that data is really important, and many organizations around the world have actually realized this, and they transition more into like a data-centric approach. So what is data-centric? It basically means making really important business decisions and answering critical business questions like how can we improve our products, how can we improve our services, which market we should go after next, and things like this. They make those business decisions based on data. So there's no deny that data is really important, and nowadays it's a strategic asset to every organization. But the question now comes, how can we actually make value of this data? So over the past couple of years, we have seen an explosion in terms of new data sources coming into the picture. So things like IoT devices, clickstream data, security logs, mobile logs, and many other data sources. All of these data are obviously different, and each comes with its own complexities, structure, format. So we need to find a mechanism to be able to capture those data sources and gain insights from them. And we also want to make sure that we give access to this data to many people and many applications. This could be inside our organization or outside our organization. And this is something called data democratization. And of course, we want to do this in a secure way. We do not want to give access to the data to everyone. So the best thing here to do is to be able to know, because we're working with these new data sources, it's difficult for us to anticipate like the volumes and the variety of the data that we can have. So this traditionally was a challenge. So before, in the old days, customers or organizations used to had to make this trade-off on which data to keep and which data to discard. And this was because storage was a limited resource. But with the rise of cloud computing, this was a game changer. Storage costs significantly went down, and it also gave you the ability to store a virtually unlimited amount of data. But that was not the case back then. Anyhow, this is how customers used to gain insights from the data. So they used like a traditional data warehouse model to gain insights. And oftentimes we saw that customers lived in those data silos. So each business unit or each department, they own their own set of tools and own set of data sources to gain insights from those data sources. Obviously, they're missing on the bigger picture here. So we're not maximizing the value that we can get from this data, because it's difficult to integrate those data sources together. And with the rise of those new data sources, it's also difficult to scale to be able to accommodate and store these data sources. So what we saw customers do, they transitioned more into like a data lake approach. So what are data lakes? Data lake is basically a central data repository that holds all the organization data in a single place. And then this data is accessed by other downstream applications like machine learning, BI analytics, and the traditional data warehousing. And in this model, data warehouse becomes like one branch that consumes data from the data lake. And this is a well-known architecture, which is a lake house architecture. And I'll cover this a little bit later on. So what are the benefits that data lakes have over traditional data warehouses? Well, first of all, scalability. So in data warehouses, we're talking about terabytes, and in rare cases, sometimes petabytes. And we couldn't go beyond this because it's really difficult to scale, and because compute is tightly coupled with the storage. But with data lakes, it's a different story. So you potentially have the option to scale and store up to exabytes of data, and hence the name data lake. So a lot of water, a lot of data. Anyway, so this is the first thing. Second thing, data lakes gives you this flexibility to store different types of data. This could be structured, semi-structured, or even unstructured data. And it uses well-known open formats like Parquet, ORC, and these are columnar formats that are well optimized for analytical use cases. If you compare this with the traditional model, which is data warehouses, and to put it in technical terms, in data warehouses, schemas are usually defined on writes. So what does this mean? When we're writing data into our data warehouse, we need to make sure that we're abiding by a schema that is defined inside the data warehouse. So oftentimes this was a challenge because we had like emails or maybe social media feeds. These data sources are generate semi-structured data. So we couldn't find a way to import those into our data warehouses. So this is number two. This is something else that data lakes gives over data warehouse, this flexibility. So what are the characteristics of this data lake? So first of all, we want to make sure that the data is not going anywhere. So once we store the data inside a data lake, it will stay there. And what we want to have this flexibility to store any amount of data. Because in many cases, we do not know how much data we want to store or what's our requirement. So we want to find like a way to seamlessly scale our storage platform to be able to accommodate any amounts of data. And this is why it's very important in data lakes to decouple compute from storage and be able to scale each one individually. Of course, security is really important. We need to audit access to the data. So who accessed the data and when did they do so? And be able to provide this fine-grained access control, not only on the data set level, but on an individual file level as well. So for all of these reasons, we see that S3 is the perfect fit for the storage platform of your data lake. First of all, because S3 is designed from the ground up to deliver 11 nines of durability. So your data is extremely safe in S3. And to put this into perspective, if you have 10 million objects in S3, you might lose a single object once every 10,000 years. So it's very, very safe in S3. It also gives you the option to store virtually unlimited amount of data. And at the same time, it's very secure. So it has like many different mechanisms that you can employ to make sure that you know when the data was accessed, how it was accessed, and you can also provide this fine-grained access permission up to the file level itself, and S3 terms object level. So and there are many different things that you can do with S3, like bucket policies, access control list, and many others. And S3 also comes with like many other useful benefits and features. So things like cross-region replication for disaster recovery purposes. And it also provides many different storage classes depending on your needs and access patterns that you can choose from. So for example, if you have infrequently accessed data, there is a storage class for it that offers cheaper storage options. And even if you do not know your access patterns, you can delegate this decision to S3. So S3 will analyze the data and will know which storage class this data should go to. So obviously S3 is not the only service that makes up our data lake story. It's rather complemented by many other services, and this is what we'll look into in this session. So for this reason, hundreds of thousands of customers chose to build their data lakes on AWS. And this is only a very small sample of the number of customers that are building data lakes on AWS. And you can see here that there are customers from different industries, each with their own set of use cases. They're using AWS S3 as a storage platform and other AWS services to implement any use case that they have. So what are the reasons that they chose AWS for? Well, first of all, it's very easy to build data lakes on AWS. Second, it's very scalable, so you can virtually store unlimited amount of data and give access to this data to virtually unlimited amount of people and applications. And then the third thing, AWS provides this rich ecosystem of like a list of comprehensive tools and services that you can either use individually or collectively to implement basically any use case that you have. And this is the point that I'd like to spend the rest of the presentation on, which is point number 3, the rich ecosystem that AWS provides. But before doing so, I'd like to walk you through a typical analytics stack and how does it look like. And this is not only on AWS, so it's exactly the same anywhere else. So moving bottom up, it starts with data movement. This is all about ingesting data into your data lake. And then moving up, you have the core infrastructure. This is like the storage platform and all your security policies go in there. Maybe you want to catalog the data, classify the data. This is the core infrastructure of the data lake itself. And then moving up the analytics, there are different types of analytics. You have real-time analytics, batch analytics, operation analytics, and many others. And then finally, it's the presentation layer where you present this data. This could be in a form of dashboards, or it could be an input to a machine learning model, for example. So mapping some of our services to these layers, this is how it would look like. This is only a sample of our services. I cannot fit all of the services into the slide. And unfortunately, I cannot go over all of these services in today's session. So I chose a subset to go through. But the point that I'm trying to make here is that there are many different services that you can use from. And the best thing is those services are deeply integrated with each other. So all of these layers are deep. You can easily integrate services from different layers together. So let's start with data movement. And this is all about loading data into the data lake. There are two different types of data movement. The first is the traditional way of like moving from your traditional data sources like databases or NFS shares, and then you have streaming data. This is like the more modern. So let's focus on the first method first, which is the traditional data movement method. This is further divided into two different types. The first is the offline mechanism. And this is when you're physically transferring the data and ingesting the data into your data lake. You might have your data source in an isolated network with limited internet connectivity or limited bandwidth, and you want to easily ingest this data into your data lake, but because you do not have internet connectivity, you cannot. So what you would do, you would use physical appliances to ingest this data into your data lake. So for this, we have the Snow family, and this consists of three different physical devices. First, Snow Cone, which is very small, it's like big of my hand, size of my hand. And then you have Snowball Edge, and you have Snowmobile. So choosing which device depends on your needs and the amount of data that you want to ingest into the data lake. So this is the first type, which is offline mechanism. So you're basically physically transferring the data into the data lake. And the second type is the online mechanism. And this is when you're transferring the data over the wire. So this could be over the internet or over a VPN connection between your on-prem data center and AWS, or it could be a dedicated connection that you have between your on-prem and AWS, which is called Direct Connect in AWS. So if your data source is like traditional operational databases, you can use a service called Database Migration Service. And what this does is that it monitors your data sources, your operational databases, and captures any changes and replicates those changes into your data lake. So it's called it's something called change data capture. And then if you have your data sources as NFS file shares, for example, or SMB shares, you can use a service called DataSync, which is a fully managed service that accelerates the delivery of data from your storage systems into the data lake. Obviously, these are only two different, services in the online mechanism. There are many others. Like for example, if you have SFTP workloads, you can use the AWS Transfer family to ingest data into your data lake. There are many other services in this area. The second type is real-time streaming data. And this type of data is gaining a lot of popularity recently, and I'll tell you why a little bit later on. But anyway, so what is streaming data? Streaming data is data that is continuously generated from different data sources. So things like IoT devices, clickstream data, and many others. So what do we want to do? We want to be able to capture this data and maybe analyze this data in real time. For example, if you want to provide recommendations in real time, or maybe you want to transform this data on the fly before persisting it into our data lake. So for this, we have the Kinesis family. It's composed of 4 different services. The third one here, Kinesis Data Analytics, is not really a data movement service, although you can use it for data movement, but it's more of an analytics service, and you typically use it to analyze the data in real time. I'll cover this a little bit later on. The fourth one, Kinesis Video Stream. So as the name suggests, it's a fully managed service that enables you to capture live video feeds and then send those videos to downstream applications. Like this could be machine learning or any other data processing tool. And a really good use case for Kinesis Video Streams is home security. You can have cameras installed in your home and you capture live video feeds, and you want to be able to detect in real time if there is an intruder coming into your home, for example. For this, you would use Kinesis Video Streams. But the 2 services that I'd like to really spend some time on is Kinesis Data Streams and Kinesis Data Firehose. Both of these services are fully managed services that enable you to capture streaming data in real time. But with Kinesis Data Streams, it gives you the ability to store the data for a specific retention period that you specify, up to 1 year. And then you have consumers on the other side consuming this data from the stream. You can have multiple consumers consuming the same event. So in essence, you're fanning out the event to multiple consumers. So if you have multiple use cases, like for example, fraud detection and personalization or recommendation, for example, you can have multiple consumers consuming the same event. You can also go back in time and replay events as they occurred. And this is really useful in event sourcing use case, for example. So Kinesis Data Streams is fully managed, so you don't need to worry about infrastructure or software or anything. You just need to specify the throughput that you need for your stream. But if you want an easier way to load data into your data lake, then I would go with Kinesis Data Firehose. So Kinesis Data Firehose is the easiest way to reliably load data into your data lake. And it's not only data lake, you can choose one of 5 destinations. So S3 is one of them. And you have Redshift, which is our cloud native data warehouse, Elasticsearch, Splunk, or any HTTP endpoint. And with Kinesis Data Firehose, it's even more, I'd say, more fully managed. So you do not need to specify the throughput. You just capture the data and choose one destination. So this is the Kinesis family. It has been there for a long time. Thousands of customers are using it. But I can sense that some of you out there might be asking the question, okay, so we're talking about streaming data. So what about the beast of streaming? And I'm glad you asked. Yes, we do have a managed service for Apache Kafka. So Kafka is for those of you who do not know Kafka, Kafka is an open source distributed event streaming platform. It's very, very popular. And in fact, it's the second most popular Apache project out there. And more than 100,000 organizations are using Kafka at the moment. And more than 1/3 of Fortune 500 companies are using the Apache Kafka. And it's responsible for handling over 1 trillion events a day. So it's very, very popular. And it comes with its own rich ecosystem of tools that you can use together with Kafka to implement any streaming application use case that you might have. But for those of you who know Kafka, you would know that although Kafka is really powerful, it's very difficult to manage. So there are so many things you need to take into account. So things like high availability and making sure, because Kafka is very flexible, it gives you the flexibility to configure your cluster according to your needs. So there are so many different configuration parameters that you put. So oftentimes you spend a lot of time in managing Kafka itself. So for this, we released managed streaming for Kafka. So it's basically a managed Kafka service. So we manage Kafka on your behalf, and you would focus on building streaming applications instead. So what are the things that MSK does for you? Well, first of all, it monitors the cluster itself and makes sure that any broker or server inside your Kafka cluster, if it detected any unhealthy brokers, it automatically replaces those with new brokers. It takes care of high availability. You can also easily implement multiple levels of security. So if, for example, you want to enable mutual authentication in Kafka, you can easily do this with MSK. And then the best part is that you can, when it comes to upgrades. So you would initiate a Kafka upgrade. So you want to move to a newer version of Kafka. And then we will take care of the upgrade itself without any impact on the cluster itself. So normal read-write operations will happen on the cluster. One of the good things about MSK is that we did not fork like the code base of Kafka, open source Kafka. So we're using the exact same code base as the open source Kafka. So any tool that you would be using with Kafka would work seamlessly with MSK, with exception to a few tools that require you to install jar files inside the brokers, which is currently not supported in Kafka, MSK, sorry. So this is Kafka. It's very similar to Kinesis. And as I sensed the last slide that some of you might be asking, okay, where is Kafka? I can sense that some of you might be wondering, okay, so which one should I use, Kafka or Kinesis? Unfortunately, I cannot answer this question in this session because it requires a session on its own. But the really quick answer is that if you're looking for deep native integrations with many different AWS services, and the easiest way to get started with streaming applications, then I would look into Kinesis Data Streams. But if you're looking for the flexibility of the open source community and the different tools that you want to have with your streaming platform, then I would look into Kafka or MSK. But there are obviously many other factors like the size of the event, the retention period that you want to have inside the stream, the skill set that you have in-house for different programming languages. And there are many more. So there are many different factors that you need to take into consideration to be able to make this decision. Please reach out to us if you need help in making this decision. So this is how we load data into the data lake. Now we move up the stack. Let's go to the core infrastructure. So I've already talked about the heart of the data lake, which is S3. So I'll not be talking about S3 again. But now, because we're working with data lakes, then we need, with data lakes, schemas are defined on reads. So what this means is that when you have downstream applications reading the data, it needs to know how the schema of the data looks like, so it would be able to access this data. So for those of you who are coming from the Hadoop world, would have known something called Hive. So Hive is basically a meta store that holds the schema of the data. And for this, in AWS world, we have AWS Glue. AWS Glue is a managed service that provides 3 different functionalities. And I call them the triple Ds. The first is Discover. So it discovers the data using the Glue data, which is a fully managed Hive compatible data catalog, basically. So how would you populate this data catalog? You can use the APIs, you can use the console, or you can use crawlers. Crawlers would crawl your data sources, scan the data, and infer the schema and populate back the data catalog. So now you have the data catalog. You're able to start the analytics, or downstream applications can start reading the data. But oftentimes, especially when we're working with like these new data sources, data will not be clean. It will be dirty. So things like null values, duplicates. So what you want to do, you want to do some initial transformations to this data and maybe move this data from a raw bucket or a raw folder to a curated folder. So you need some sort of an ETL job to run. So the second functionality that the group provides is it helps you develop this ETL script. So it helps you in the development phase, second D, development. So it automatically generates the code for you to use in your ETL. You can either customize this code according to your needs, or you can use this code as it is, plug and play. And then when you then you move to the third thing that Glue provides, which is deployment. So you would then deploy this into a job, and Glue uses a serverless execution model. So you can either use a fully managed Apache Spark environment, or you can use a fully managed Python shell environment for simpler jobs. But then you can have multiple jobs in your data pipeline. You can connect those jobs together in a workflow. And there's another feature that Glue provides, which is workflow management. And this only works with Glue-based jobs. So if you have other non-Glue-based jobs in your data pipeline, like AWS Lambda, for example, which is our serverless compute service, then you can use other orchestrators like step functions or Airflow, which is another very popular open source orchestrator. And we do have a managed service for Airflow as well. So anyway, let's stop for a minute. Let me drink. And think for a second what we've actually done. So you would immediately realize that building data lakes is not an easy task. It's not a walk in the park task. So we need to think about how can I move data into the data lake? And then how can I clean this data and catalog the data so it be able to serve it to other applications? And then before you serve it, you want to make sure that you have the security policies in place so that not everyone will have access to everything. So for this reason, we launched AWS Lake Formation. And this is a fully managed service that simplifies the process of building data lakes on AWS. So instead of spending like weeks or months building a data lake, you can potentially, with Lake Formation, build a data lake in days or even hours in many cases. It comes with many really nice features, like blueprints that helps you with loading data into your data lake, a data catalog that is based on the Glue data catalog. But what makes Lake Formation very powerful is this centralized permission model that it has. So you can control access to your data from a single place, which is the Lake Formation console. And not only on the database level or the table level, but you can also go to the column level and provide column level security. And also in the last re:Invent, we announced the support for row level security as well, but this feature is in preview at the moment. So with Lake Formation, it also supports cross-account access, because oftentimes met with customers that adopt like a multi-account strategy where each department has its own set of AWS accounts. They can have applications sitting inside other AWS accounts, accessing data inside the centralized account using Lake Formation. This is something that is supported in Lake Formation. And the best thing in Lake Formation is that it's free of charge. You only pay for the services that Lake Formation uses under the hood. Anyway, this is how we loaded the data, and then we secured the data, cataloged the data. Now the fun begins. Let's analyze the data. So I've broken this into two different parts. The first is batch analytics, and the second is real-time analytics. So I'll start with Amazon Redshift. For those of you who are coming from the data warehouse world, this would really resonate with them. So Amazon Redshift is our cloud native petabyte scale data warehouse. And what we often see customers do is that they extend Redshift and integrate Redshift with the data lake. And this is what it's called lakehouse architecture. So basically, it's like a hot-cold pattern where hot frequently accessed data stays in Redshift, and then cold infrequently accessed data goes into the data lake. Users submitting the queries will not have to submit the location of the data. They will submit the queries the normal way, and Redshift will know where to fetch this data from. Also, Redshift is a very active service. We continuously release new features in Redshift to cater all of our customer needs. So things like RA3 nodes that decouple storage from compute, Aqua that provides 10 times better performance, Redshift ML that integrates Redshift with our ML stack, and many other features that Redshift offers. But oftentimes customers say, okay, we have data, we do not know whether this data should go in a data warehouse or not. Or maybe we do not know even if this data is valuable for us or not. And we need some sort of a mechanism to be able to analyze this data on an ad hoc basis. For this, we have Amazon Athena. Athena is a fully managed interactive query service that enables you to query data inside your data lake using standard SQL. And in my opinion, it's the easiest way to get started with analytics on AWS. Because it's serverless, you don't need to set up any infrastructure. You simply point Athena to your data lake, and this is what Nitin will show us a little bit later on in the demo. And that's it. You can immediately get started. And because it uses SQL, then for those of you who are coming from a SQL background, you can easily get started with Athena. And Athena, you get charged on the amount of data that Athena scans. That's why we always recommend our customers to optimize the storage layer and limit the amount of data that Athena scans. So employing things like partitioning the data, compressing the data, using columnar formats, these are all mechanisms that limit the amount of data that Athena scans. And because you're limiting the amount of data that Athena scans, you're improving performance and reducing cost at the same time. So this is Athena. It's one of my favorite services. I'm a huge advocate of Athena. And you can use it in many different use cases, and those use cases are available on our website. But one use case that has recently emerged and I've seen been used by many customers is text analytics. So imagine if you have customer reviews and you want to be able to detect sentiment from those reviews, or maybe you want to translate those reviews from German to English, for example. So what you can do, you can use Athena user-defined functions to integrate Athena with our AI services to do this for you and to further analyze this text. So this has been gaining a lot of popularity recently, and for this reason, I published a workshop on this specific use case, which is Athena Text Analytics, and I published this last week. Please make sure to check it out. I will share the link after today's session. The first two services, Athena and Redshift, are more in the batch world. EMR works both. It could be in batch and real time as well. So EMR stands for Elastic MapReduce. And for those of you who are coming from the Hadoop world, this would resonate with them. It's often compared with Glue, especially when we're talking about Spark, but EMR gives you the flexibility to use 21 other big data frameworks like Hive, Presto, Flink, HBase, and many more. Also, EMR is server-based, so you need, when you're creating an EMR cluster, you need to specify the number of task nodes and core nodes. You can follow our templates, and EMR will deploy the cluster for you automatically, but still, in the background, there are servers that you can SSH into. So it gives you this flexibility to customize your cluster according to your needs. It also supports different pricing models like spot, which is the cheapest way to run compute on AWS, and reserved instances. And you can also use EMR to extend the EMR cluster and use the storage inside S3. So again, lakehouse architecture. And this is a feature called EMR FS. So the service that we talked about so far is real time, is batch, with exception to EMR. But then I want to highlight here, or stop for a second and say, ask a question out loud. Why is real-time data gaining so much popularity recently? Well, if you think about it, the older the data gets, the less value the data will hold. So a really good example is fraud detection. So imagine you have millions of financial transactions every day. And at the end of the day, at midnight, a batch job will run to identify any fraudulent transactions. And then this job will run for 6 hours. So imagine you waking up 6 a.m. in the morning with this job producing really nice dashboards for you, telling you that you had 10,000 fraudulent transactions the previous day. So it's really good that we're able to identify this, but I think we're a little bit too late. So to put it simple, the earlier we react to a detected situation, the more powerful the reaction is. And for this reason, real-time is gaining so much popularity. So when I'm talking about real-time, two very popular open source frameworks immediately pop into my mind. The first, Apache Flink, second, Apache Spark. Both are distributed data processing frameworks, and they have the ability to work with bounded data sets and unbounded data sets, so streaming data. And they simplify a lot of the complexities that you would get with the streaming data. So things like exactly one semantics, built-in fault tolerance using checkpointing, so that when a cluster fails, it picks up where it left off, basically. And they also come with this rich ecosystem of tools and connectors that source connectors and sync connectors that help you integrate with source and sync. So they easily integrate with MSK, Kinesis, and Vanilla Kafka. We do have managed services for both frameworks. So again, Glue making an appearance. It's based on Spark. Kinesis Data Analytics, the service that I was talking to you about previously, is a managed Flink service. So which one would you use? Again, this depends on the use case. For example, how they handle streaming data. So KDA, Kinesis Data Analytics, it uses this native streaming mode. So it processes each event as and when it arrives inside the stream. Whereas Glue uses a micro batching model. So it has like an open window, and all events that occurred within this window are processed together in one go. So Flink is a little bit faster. So anyway, this is how we analyze the data in real time. We're able to detect fraudulent transactions in real time. We're not late and stop them. Now, in my opinion, this is the best part, gaining insights from the data. This could be an input to a machine learning model, and this will open the horizon to many different use cases, like forecasting, fraud detection, predictive analytics, and many more. So I'll not cover AI ML. I leave this to next week, where Ozzy and Emilia, my colleagues, will be walking us through our AI ML stack. And I want to focus on building stunning dashboards and presenting those dashboards to our stakeholders. And for this, you would use Amazon QuickSight. So this is a fully managed business intelligence tool. And because it's fully managed, its scalability, high availability comes baked in by default. You don't need to worry about this. So you can easily scale from, I'd say, hundreds of tens of users to tens of thousands of users. And you don't even need to pay for those users. You only pay when those users access your dashboards. So you're basically only paying for value. QuickSight has many other benefits, and because security is a top priority for us, let me start with security. One, it integrates with IAM to provide fine-grained access permissions. It's also able to access your private data sources, whether it's on-prem or in AWS, using private VPC connectivity. And it has really nice security features for multi-tenanted environments. So things like namespaces to isolate groups from different tenants, or row-level security, and many others. There are two really nice features that QuickSight has as well. So the first is ML Insights. So you can easily add forecasting and anomaly detection to our dashboards without any machine learning experience required. And this is what Nitin will show us shortly. And then you also, with QuickSight, you have this feature called SPICE, which is super fast parallel in-memory calculation engine. And this is essentially a layer that sits between your end users and your back-end resources. So if you have tens of thousands of users accessing your data sources at the same time, you do not want to overwhelm your data sources. So what you would do, you would ingest this data into SPICE, and because SPICE is fully managed, it will be able to accommodate this high number of concurrency. So that's it for me. I've been speaking for quite a bit. Now it's time to see some of this in action. Nitin, please take it away.
Perfect. Thanks, Ahmed, for a very insightful presentation and giving making my life quite simple. I don't have to deep dive. I'm just gonna pick up a couple of services from the plethora of services which Ahmed touched upon. The services are Amazon Athena and Amazon QuickSight. So basically what we're going to do here is, you can see that this is a serverless demonstration of using Amazon Athena for querying and analyzing data, which is available in S3 via any data set that you may have, and then visualizing that data into machine learning powered business intelligence dashboards. So we'll quickly look into that. The piece that we are going to develop is going to be two-part. One where we'll be looking at the querying via Amazon Athena, looking at the data which is in CSV format, and also working with data which is in Parquet format. And as Ahmed already touched upon, the Parquet format is very common. Parquet or columnar format is very common in the data analytics domain. We'll also be using data catalog because Athena stores the metadata information only and not the corresponding data. So basically, it has the information about the table structure, attributes, fields, types, and the database in the metadata store. And the data is always in S3, even with respect to the queries that you run. The query results are stored in Amazon S3. Then the second part of it is we're going to use Amazon QuickSight integrated with Amazon Athena with the tables that we created, and do a presentation and visualize the data that we have received. Okay, so without further ado, we'll crack on with it. Just a little touch base on the data that we have. We're going to use a public data set, which is basically a data about all trips completed in yellow and green taxis in New York City in duration of 2009 to 2016. And it also includes the trips by for hire vehicles from 2015 to 2016. And the rows include fields like pickup and drop-off times and date, pickup and drop-off locations, trip distances, itemized fares, rate types, payment types, and the number of passenger counts provided by the driver. So this data set is already partitioned and in CSV and converted from CSV to Parquet format. So we have both the formats available in S3. So let's get going. So the first starting point, as you would have seen in the presentation already, is the core is Amazon S3, where the data is. So we'll start by creating one bucket, which is query results 22. As in, we can create name. It has to be a unique name in the domain of Amazon S3, which is simple storage service. I just named it as query results 22 because it's very hard to find a unique name if you are going for something so predictable. So the next stage is Athena. In Athena, we have to start with creating a database. For the simplicity of the demo, I already created a database called My Database. Okay. The next stage is to create table with with the S3 data. The data is stored in S3. We are working with public data, which is already available, public data set. So we're going to point to this S3 location. Now, the point to note here is that this data set could be in any other AWS account or any other region. Amazon Athena will work just fine to fetch the data and present it in Athena Query Engine. So I already did that for you. This data is in CSV format. The inputs to supply are the name of the attributes, the type, the delimiter parameter, in this case is a comma. And we also have to declare that is the external keyword because that is how the meta store is works. And then and just one point to note that if we drop any tables from this query engine from Athena, it does not impact the data stored in Amazon S3. Okay, let's get on with the query. So currently we have the CSV data stored in the table called techELITE yellow. If we just quickly do a run, we can see it's going to take some time and it's going to scan 280 MB of records while we are actually limiting it to only 10 records. And I've run some queries and recorded the time here because if you can see that a query which actually has to get the count of all the records in this table, it will take roughly around 17 seconds and it is going to scan around 207 GB of data. With the query engine, you also have most of the aggregator functions like average, total, and the case functions as well, the expressions. This query only demonstrate the usage of that. Again, in the interest of time, I'm going to save time and I just gave you the time that it's going to take around 20 seconds. We're going to revisit these queries once we have the optimized data table. So we are currently working on the CSV format data, while the recommended format is POCI or ORC in the data analytics field. So, so let's go ahead and work with such data types. So we have another data set which is in POCI format. As I mentioned in the beginning, we already have converted this data and partitioned it and placed it in the POCI format. So we have this data set available in S3 location. We can use this query, which is again specifies the attributes, types, and the partition to be created. So this partition is actually going to be done by the metastore. So partition will be in the metastore, and we chose year, month, and type. Mostly the partition is recommended to be on time. You like time components like year, month, date, and so we're just following the best practice here. It's stored as Pocket, which basically indicates that the format of the data is POCI. And let's say if we can quickly do a run on this and see that we have retrieved this result in 1.54 seconds as compared to this one, which took roughly around 4 to 5 seconds. So let's compare the data side by side now from the two tables and compare. So this is the CSV format data, which is unpartitioned. And we can see is going already upwards of 7 to 8 seconds. So the earlier runs, which ran up to 15 seconds. So yeah, 15 seconds with 207 GB of data scanned. And the interesting part is something which we'll see here. If we run the similar count query on New York taxi rides table, we can see the query result has come back in 3.43 seconds. However, the data scan is 0 KB, and that is because of the underlying query is not actually scanning the data, but is actually scanning the metadata information and can give you this data from the metadata itself. it gives you the count, but it doesn't scan the whole data set. Okay. Now, there's one more feature, which is basically you can convert your existing raw data from other storage format to Parquet format. And you can use this function called create table as select to do that. And this command only demonstrates that how would you do that. And you can specify an external location for S3 where the data will be stored, and just run this command. It will repartition as in case, because right now we are just looking at our existing table. So it can repartition this table and data and convert into Parquet format. Now, this is about the querying part. And let's go to the visualization part, and we go to QuickSight. Now in QuickSight, to get started, I already have a data set created here, but just to give you an overview of how you would get working with setting it up to work against Amazon Athena, I'll quickly walk you through the process. So we have to go to the Northern Virginia region to be able to change some of the permissions. So let's say we go to security informations. This is where we have to add a source where QuickSight will look for the data. I've added Amazon Athena already. And you just have to add or remove to get Amazon Athena working here. And then you can choose your location for S3 as well. And when you choose S3, it shows you the options, which I'll walk you through in the dataset section. So let's go back to Oregon region where our rest of the data is. This is where you can see that we are working in US West Oregon region. So for the QuickSight to be able to automatically pull up the data set, we should go in the same region. Let's choose Athena and create a new data source. It is going to look into the catalog for available databases. It shows the My database that we had in Athena, and we can choose the table here, which we want to visualize here. I've done this already, so I'll not repeat the process. Instead, go and jump into the visualization and the dashboard. Okay. So let's start with a simple visualization. When you see that, when you land onto this this page, you will see that your table or data set is selected here. You can choose one of the fields from the left-hand side from the field list to see the data here. Currently, you have some filters. Again, let's say quickly select all. I'll just remove these filters. And I chose year from the visualization, and you can see the data. So let's change the graph to autograph. Okay, so this is the complete data set. You can see there's this comma appearing. You can change this to a different format. Let's say 1, 2, 3, 4. So 1, 2, 3, 5. So you can see the data is changing here. You can also add calculated fields where basically, for example, this field is not one of the data set, but is something which you can add additionally on top with the calculation. So let's say we narrow down our visualization. And add a couple of, let's do filters. So we have to do the number to be right. So you can see the year there and the corresponding number of trips. Let's add filters. And let's filter by year. Let's see the 2016 record, because in 2016 we had the trips from both the sources, hire for vehicles and yellow and green taxis as well. So that's, you can see the data is filtered onto 2016. Let's also narrow it down in terms of month as well. So let's visualize, filter. And stick to January. Yeah, and here we can choose month as well. We can also use aggregate functions here. Now at this stage. Okay, so yeah, so we can see these visualizations. Let's change the graph to line chart to be able to visualize these numbers more and aggregate it. One second. Yep, so there's another format here. Okay. Now, the next thing which we can do here is, give me 1 second. Yeah, so all right. It took a while, but I think we're finally there. Right, now we can actually narrow down. You can see that it has worked out all the months and the counts for every month in the bars. We can now add a filter on the basis of month. Yep, it has removed it. No, so it, okay, removed because it has done or instead of and. So let me just quickly change it. Okay. Yeah, sorry. Okay, now we'll filter. This is the and condition here, and we narrow it down instead of doing either or. Okay, apply and visualize here. So we have a 1 month data, and we'll now change it to the line chart to be able to see the data for the month. Okay, now if we remove the month, and for this particular month, which is January 2016, and see the fluctuation over the hours, you can quickly see this variation. Now, I'm conscious of time. I'll quickly walk you through the visualization part, which is where the machine learning aspect comes into the picture. So what we'll do here is add another comparison, which is against the type. And you can see that the graph is against the number of trips in the month of January on the split across the hour of the day, and the 3 types of taxis that we have for hire vehicles, green and yellow. And we can easily spot there is a trend here, which is an anomaly. And we can see that this is for the date of 23rd January. And we can quickly find out that what happened on the date of 23rd January 2016. The first point is major snowstorm blankets East Coast, which tells the story why there is a dip in the taxi rides there. Now looks into the forecasting part of it, which is the interesting part and machine learning driven. So let's add this visual. We'll choose this and do on the pickup date and time. Let's run on the monthly basis. While we have this graph, which looks very nice, but changing it to line will make more sense. Now, the interesting part is that this is just a visualization. The interesting thing comes here is that we can automatically enable the anomaly detection as well as set up forecasting. So if we enable the forecasting, the machine learning engine behind QuickSight will actually give you a next 6 months prediction on the basis of the data that we already captured. So this is it from the demo point of view. We go back to the presentation where we see that where we go from here. There is no reason why you should stop learning. You had a presentation, you looked into some bit of how to make it work, but there is more beyond it. As Ahmed mentioned, he created a workshop which you can look at. We'll share the link later on. But we also have a free digital course called Data Analytics Fundamentals, which is highly recommended. There are some classroom offerings as well. And at the end of it, just to certify and validate your skill sets, you can also go through the AWS Certified Data Analytics Specialty exam. That's where I wrap it up. Thank you very much for bearing with me.
Thank you very much for that, Nitin. That's fantastic. We've got some good questions to go through. So taking the first one, when should we use Athena as against Redshift?
Good question. So basically, these are 2 separate use cases. Both address different needs, and you just need to find the right tool for the right job. So while Amazon Redshift provides the fastest query performance for enterprise reporting and business intelligence workloads, particularly those involving extremely complex SQL with multiple joins and subqueries. But on the other hand, Amazon Athena is basically going to give you an easiest way to ad hoc query on data, which is stored in S3, without need to set up any manager setup or any server management. So that's precisely sums it up on a high level.
Thank you for that. What is the difference between queuing systems like RabbitMQ and streams like Kafka or Kinesis?
Yeah, so I can take this. Again, they both serve different purposes. So the queuing systems like RabbitMQ or SQS, they decouple producers and consumers from each other. But with queuing systems, usually when the message is consumed, it's deleted after it's consumed. So you do not have this ability to go back in time and replay events. So this is especially useful in event sourcing use case. This is one point. And then another point is in queuing system, it's often difficult in many of them. It's often difficult to order the events to strictly follow the strict order of the events and when they occurred and when they were written into the system. But whereas in Kafka and Kinesis, it's a different case. So you can easily configure this. It's automatically done in Kinesis on a shard level and in Kafka on a partition level.
You mentioned partitioning as the best practice when working with Athena. How can we partition the data?
Yeah, so there are different mechanisms in how you can follow and partition the data. So I always recommend customers to look at the use case and the queries that they submit against Athena. And if they're using QuickSight, look at the queries that they're submitting against QuickSight and work backwards from there. So if they're, for example, frequently filtering by year or by month, then they partition by year or month. There are different types of partitioning. There's multi-level, so you can have like a year, and then inside the year you have months, and then inside the month you have a day. Or you can have a flat scheme, which is often easier when you're writing queries. So you can have like date, and then equal year, month, a day. So it's more flat. It's a little bit easier to manage and easier to write queries as well.
To use the ML tools, do users need to have significant maths skills?
Yeah, I can take this one as well. So well, again, it depends on the tools that they are using. So there are tools, we have services that gives you the flexibility and to basically do whatever you want. So things like if you're working on the on EC2 directly and using the frameworks like TensorFlow or PyTorch, then you would need to have like ML experience, obviously. But if you want to use our AI services, like this is the opposite, like comprehend, the text track, translate, you do not need to have any ML experience or any math. You only need to know how to invoke the APIs, basically.
Is there a built-in data lineage tool, or is it quite easy to trace back data used in an analytic output?
So I can take this one as well. So with data lineage, it's so we do have services that offer data lineage. So for example, Data Brew, it's a service that I didn't cover in my presentation. So this is a visual data preparation tool. And one of the things that Data Brew provides is like data lineage. Where did the data come from and what happened to the data and how did it look like inside the journey? But there are other open source tools that they can use and install on EMR. So this is a service that I talked about, EMR, Elastic MapReduce. They can use other big data frameworks and install those tools in EMR.
Nitin, you were using the data set of taxicab journeys. We're being asked, where can we get that from? I think you said it was publicly available.
Yeah, it's publicly available on S3 buckets. We can send across the link to those data sets.
Okay, we can share that link along with the other ones that you've mentioned. Thank you. We're being asked that one of the audience could see you were using Chrome. Does it work also on Safari?
Which specific service? Yeah, it should ideally work because yeah, it's the console experience, and it should work across the browsers.
And finally, is it possible to create custom visual types in QuickSight?
Unfortunately, I do not get the question. So what do you mean by custom visual type? So there are different visuals that you can choose from, and you can ask QuickSight to select the visual based on the columns that you selected. But creating a new visual, no, this is something that is not available in QuickSight.
There's just one final question in that we can just squeeze in. When the source system has produced wrong data, in order to get correct BI reporting, it should be corrected by the same source system as well with different events, or with should it be corrected by the same source system or with a transformation pipeline from raw to curated zone of data lake? Asks Anna.
Yeah, so this is normally something that is fixed in the ETL process. So you would run a job. So it depends. So if you're running like a real-time streaming job, then you can do this on the fly before you persist it, or you can have a job that runs on a scheduled basis and would do this on a batch process. And I don't know if I mentioned this there is also an open source, I think I did. There is an open source project called Beam, which stands for batch and stream. So, and the aim of this project is to unify the code base from streaming and batch in one pipeline. So you can use Beam to make this correction.
Thank you for that. And that is the end of the questions, which brings us perfectly to the close of the webinar. Thank you very much indeed to our speakers, Ahmed Zamzam and Nitin Tiwari. You've given us an amazing insight into data analytics on AWS, and really, I think, given our audience some things to think about. We'll share the recording of this session with you in the next day or two, probably tomorrow. And before you close your browser, you'll see a survey. It's very short, and we would really appreciate your feedback on this very technical session. If you're in a rush, don't worry, the link will be included in a feedback email in an hour's time as well. I hope you've enjoyed this session. Thank you to AWS. We will share also the links that Nitin and Ahmed have mentioned. And thank you to our speakers, Ahmed and Nitin. It's very much appreciated. I hope to see everybody next Thursday. In the meantime, thank you for attending and goodbye.
Thank you.